Hello friends, welcome to CEC live lectures. Dear friends, today in computer science, we will be discussing about the concept of OSI model and network devices. In the first half of the lecture, we will be discussing essentially about OSI models. To discuss this topic, we have the subjects by Dr. Pavitra Bharadwaj. Dr. Bharadwaj is Assistant Professor in Department of Computer Science in JMC College, University of Delhi. Without further ado, I would like to welcome ma'am to our studios and request her to start the lecture. Welcome, ma'am.
Good afternoon. Today we are going to talk about computer networks. Basically, we are going to discuss the topic of OSI model and some network devices where they are placed with respect to the OSI model. Before we begin with the OSI model, let us just take a quick recap at what is a computer network. So basically, a computer network is an interconnection of computers for the purpose of resource and information sharing, communication, and other important network services. Now, a network is composed of a sender and a receiver. So basically, a network is a combination of hardware and software that carries the data from one computer to the other. So when we say hardware, it is the physical equipment that carries the signal, and software means the instruction set that makes all network functions possible. So hardware means all the devices that are there, the media, that is the wires, the cables, the optical fibers, or the wireless apparatus like the radio signals or any kind of other wireless technology, the microwave signals which are used for transmitting data from one computer to the other. All these come under hardware, networking hardware. Along with hardware, software has a key role to play when information is transmitted from the network. So both the hardware and the software together are most important for transmission of any kind of data, instructions or information over a network. Now, in case of computer networks, the approach that is used for understanding the way information travels from one computer to the other is utilizing the layered approach. Layered approach means that the basic function of transmitting of one event or one data from one computer to the other computer is subdivided into distinct elements or distinct steps. We can compare it to the sending of an email message on a computer network. So the entire process of sending an email by one computer and receiving the same message by the other computer is further broken down into a number of steps, and each step can be carried on by a specific layer. So we use the concept of layers in our daily life also. Like for example, if we say that a friend is sending a letter through normal post to another friend. Now this process of posting a letter by one friend to the other friend will also involve a number of steps, and each step can be understood as comprised of a separate layer. So we have a sender, we have a receiver, we have the message, and we have a carrier which is going to carry the information or the message. So this slide, if you will see here, it shows the tasks involved in sending a postal mail. For example, the sender will write the letter, put it in an envelope, drop it in the box. Then the letter is carried from the mailbox to the post office. Then the letter is delivered by the carrier to the post office. On the other side, at the receiving end, the steps are just the opposite. First, the letter is delivered from the carrier to the post office. Then it is carried from the post office to the mailbox, and then the letter is picked up, removed from the envelope and read. So we can see that the steps for sending a letter from the sender to the receiver, they are followed in a layered manner. Now we talk about the OSI model. After we have discussed how the layered approach is used in understanding networks, we will see what is the OSI model. Actually, what led to the growth of the OSI model is that there was a rapid proliferation in the number of computers, which required that the process of information interchange on the network to be standardized. So, for this, the International Standards Organization, that is the ISO, which was founded in 1947, it laid some guidelines for communication over the network. So, this model is known as the Open Systems Interconnection Model or the OSI model. So, the OSI model stands for Open System Interconnection, and it consists of 7 layers. The use of layers is designed to reduce the complexity and make standardization easier. So, basically ISO is the organization and OSI is the model. OSI is actually not a protocol, it is not any kind of rule or a convention, but it is simply a way of how complexity can be reduced on the computer network and how information is traveling on the network from one computer to the other. So, basically the OSI model talks about layers, 7 different layers of communication. Each layer has a specific function to perform when communication is taking place, and each layer is connected to 2 layers, one above it and the other below it. So, now we will talk in detail about the OSI model and the different layers of the OSI model. So, the 7 layers of the OSI model are application layer, presentation layer, sessions layer, transport layer, network layer, data link layer and the physical layer. So, these are the names of the 7 different layers of the OSI model. So, OSI is basically a layered architecture, that is each layer is connected to 2 layers as I just said. Now, what happens is that the lowest layer, that is the physical layer, is responsible for transmitting of information through the physical channel. Then we have 6 other layers above it. Each layer has a specific function to perform when the bits of data is sent to the next layer. So, once the layer receives the data, it makes some changes to the data, it adds some header or trailer information to the data and it passes on to the next lower layer. So, the changes made by the layers at the sender's end are then all redone when the message reaches the receiver's end. So, whatever information is added is actually the message gets unwrapped layer by layer and all the contents, all the header and trailer contents are removed. And finally, when the message reaches the highest level layer, that is the application layer, then all the header information is removed and the message is delivered. So, each layer has a very important and crucial role to play while message is transmitted from one computer to the other on a network. So, the designers, they separated the process of transmitting data in its most basic steps. Networking functions that had related uses were identified and grouped and layers were formed. So, each layer has a family of functions which is distinct from the other layers. Each layer calls upon the services of the layer below it and provides services to the layer above it. Each layer communicates with the corresponding layer on the other machine. This communication is governed by a set of rules and conventions called protocols. The processes running at each machine are called peer-to-peer processes. So, basically it is the interaction between the processes which are running at each layer on the 2 communicating computers. So, the layer ensures that the communication between these 2 processes, which is known as peer-to-peer processes, takes place efficiently. Then between the 2 layers we also see that there is an interface. Like in this diagram you can see that device A is communicating with device B. There are 2 intermediate nodes between the 2 also. but basically the 7 layers of device A and the 7 layers of device B are communicating to each other, and they are using the peer-to-peer protocol, which is layer specific. For each layer above the 4th, 5th, 6th and 7th layer, there is a peer-to-peer protocol which is used, and there is an interface between the two layers, like the physical and the data link layer is joined by an interface of the two layers. So basically we say that the interaction takes place at the process level and the processes are separated by each of the layers. So what are peer-to-peer processes? Each layer in the sending device adds its own information to the message it receives from the layer above it and passes the whole packet to the layer just below it. At layer 1, the message is converted into a form that can be transmitted to the receiving device. Each layer unwraps the message and takes the data meant for it. So if you see the organization of these 3 layers of the 7 layers, they can actually be grouped into two subgroups. The first 3, that is the layer 1, 2, 3, that is physical layer, data link layer and network layer. These are known as network support layers. And the top 3 layers, that is the session, presentation and application layers, these are known as user support layers. The 4th layer, that is the transport layer, is a very important layer and it acts as a link between the two subgroups of the layers. So network support layers or the physical data link and the network layer, these 3 layers are basically network support layers. Network support means that they are more or less related to the physical transmission of bits on the physical media and how the bits will be transformed into frames and how they can be transmitted over the physical media. So basically these 3 layers are more related to the hardware part, hardware as well as software part of the network. The top 3 layer, that is the application, the presentation and the session layer, are more software oriented layers and they do not have much of the role of hardware to play in the interaction between these top 3 level layers. The transport layer, basically it acts as the link between these two hardware layer, that is the network support group, and the user support layers, that is the higher level layers. So now we will see the function of each layer in detail. Now this slide shows the exchange using the OSI model, that is how each layer adds its own information into the data message. If you can see, the part depicted at the lowest part on the sending device is the yellow part is shown as the message, but each device adds its own header or trailer information. Layer 2 is the only layer which adds some trailer information or trailer bits to the message. Rest all the layers, they will add some kind of header information to the data. When the message is then transmitted over the transmission medium, the physical layer takes account of the conversion of this digital signal into an electromagnetic signal which can be transmitted on the transmission medium. When this electromagnetic signal reaches the receiving device, then it is converted back into the digital signal. Then what you can see is that as the message moves up into each of the layers, the header and the trailer are removed from the message. And finally, only the data part of the message is transferred to the receiving computer. Here we would also discuss a very important topic of data encapsulation. Data encapsulation means that each layer will add some header or trailer information. As we have just seen, each layer adds some extra information to the message of to the message which is being transmitted. But when the message goes to the layer lower to it in the hierarchy, then that entire message is treated as the data. That is, the layer number 6 will treat the whole message coming from layer number 7 as its data. It will not distinguish between the header information and the data per se. That is, both the header as well as the data will be treated as the data for the next layer. As you can see in this diagram also, that H7 plus D7 becomes the D6 for the layer H6. This part is known as encapsulation, that is, the layer which is below the higher level layer will not understand which part of the message is the data and which part of the message is the header information that was inserted by a layer above it. So, this concept of data encapsulation becomes very important when efficiently and securely the data is to be transmitted across the various network problems. So, encapsulation means that data exists at each layer contained within a unit called the protocol data unit or the PDU. PDUs are referred by two ways, either by the number of the layer and the PDU or by special names. The process by which data moves between PDUs types is called encapsulation. PDUs move through interfaces between layers which are known as service access points. Service access points are commonly known as ports also. So, these are the different PDUs of the OSI model. As we can see, the PDU name for the application layer PDU is data. For presentation, it is also called data, and for session also. When it is at the transport layer, the packet is known as a segment. The network layer data is known as a packet. At data link layer, it is called a frame, and at the physical layer, it is actually called, it is in the form of bits. So, it is called bits. So, this is how decapsulation and encapsulation takes place. Now, we are going to talk about the first layer of the OSI model, that is the physical layer. As the name itself suggests, this layer is basically going to deal with how data is physically going to be transmitted over the transmission medium. So, the functions of this layer will include data transmission rate control, flow control, how the data is going to move on into the physical medium, how the topology of the network is going to be affected or is not going to affect the way the data is going to be transmitted over the medium. So, basically the job of the physical layer is to convert the electromagnetic, the digital signals from a computer into electromagnetic signals to be transmitted on the transmission medium, and then these electromagnetic signals or optical signals which are flowing through the transmission medium are again converted into digital signals of the physical layer of the receiving computer. So, the physical layer is basically, its main function is to convert the bits of streams and transfer them into the different medium. So, it defines the characteristics of the physical medium and interfaces. It determines how bits are presented in electrical or optical signals. It controls the data transmission rate and bit synchronization. Now, what is data transmission rate? Data transmission rate basically means the number of bits that are travelling per second. So, it should have an average data transmission rate which is not too high and not too low. Bit synchronization means that the bits which the sender is sending are received by the receiver at the same time. That is, the sender and the receiver should work in synchronization with each other. So, one of the important functions of the of the physical layer is to control the rate of the data transmission over the medium, and also to see that both the sender and the receivers are ready to receive the bits and to send the bit which the receiver is going to send. Then it also controls the data transmission mode. We know that data can be transmitted using different modes. The first mode is the simplex mode. Simplex mode means that only one of the devices can be the sender of the information and the other device will always remain the receiver of the information. Then the data could also be sent in half duplex mode, that is, both the devices on the network can act as a sender as well as receiver, but any given time the control of the channel or the transmission medium will be in one particular device's control. And full duplex means that both the sender as well as the receiver can send the data simultaneously using the same medium or using two different lines. Then the physical layer also looks at the line configuration. Line configuration means whether it is a dedicated link between the sender and receiver or they are going to use a shared link. Then it also controls the topology, like different topologies have been discussed earlier also, like we have bus, ring, mesh or star topology. Say for example, if it is a mesh topology, it means there is going to be a dedicated link between each sender and receiver. So then the physical layer will send the bits of information using this terminology, using this technology in mind, that there is a dedicated link and the information can be sent at any time. But in case if it is a star topology, then the information has to be sent to the hub and then the information or the data, the message will be transmitted from the hub. So in that case there is no dedicated link between the sending computer and the receiving computer. So basically the devices which work at the physical layer level are the hubs, the router, the cables, the connectors, etc. So this slide here shows the working of the physical layer. It is responsible for movements of individual bits from one hop or node to the next. So as you can see, the physical link layer gets the data from the data link layer and it passes on this data to the transmission medium. And the physical layer of the receiving computer accepts the data from the transmission medium, which is in form of electrical or optical signals. It converts it into digital signals and then passes this data on to the data link layer of the receiving computer. The next layer that we are going to discuss is the data link layer. So the data link layer is responsible for moving frames from one hop or node to the next. In this diagram we can see that the data link layer is connected to the network layer on top and to the physical layer on the lower end. Similarly, the data link layer at the receiver's computer gets data from the physical layer and after making the requisite changes to the data, it passes it on to the network layer of the receiving computer. So the data link layer basically it ensures that the data is converted into manageable units called frames, because as we know the physical layer only sends the streams of data in the form of streams of bits. But these streams of bits are to be then divided into frames. This process is known as framing. So in case of framing, the bits are divided into segments and then these segments called frames, they become more manageable. So data link layer actually ensures that the delivery takes place from one computer to the other computer. Besides this, it also looks at the flow control. One very important function of the data link layer is the flow control. Flow control means that, for instance, if the sender computer is sending bits of data at a very fast rate and these are not getting absorbed by the receiver. So the receiver computer may get overwhelmed with this fast rate of data transmission and therefore a data flow control mechanism is to be enforced by the data link layer of the receiving computer, so that it can signal that the bits are coming at a very fast rate which are not getting absorbed by the receiving computer. Then physical addressing, it adds a header to the data specifying the sender or receiver's address, so that the connecting and also of the connecting device. So what we are trying to say here is that in case the network, the data link layer is connecting two computers on the same network, then the receiver's address will be of the device to which the message is to be transmitted. But if that computer or that device is not on the same network, then the header will contain the address of the device which is connecting the two network, that is the connecting device. So, the data link layer will insert a header into the message which will have the information about the sender of the data packet or the frame and the receiver of the frame. So, this next slide we will also talk about the different error detection and corrections, topologies, and Ethernet, token ring and ISDN are some protocols which these are used. Switches, bridges and network interface cards are the devices which work at the data link layers. Besides this, there are sub layers also like the MAC layer, the LLC layer for the logic link control, and it gives the facilities of error control and flow control as well. So, in this slide we can see that the data link layer shows a hop to hop delivery, that is the packet will be delivered from the system, that is A, to the system F. But when the packet is delivered, the sender's address initially will be of A and the receiver address will be of B. B here is not a computer but it is a router. So, this information is the same way at each hop the sender's and the receiver's address will keep on changing to that of the computer or to that of the router which is linking to the next computer.
Dear friends, in this lecture on OSI model and network devices, so far we have covered the OSI models, and on that note we are going to take a break, and after the break we will be resuming with the lecture. Thank you for watching. Hello friends, welcome to CEC live lectures. Dear friends, in this lecture on OSI model and networking devices, so far we are doing OSI models. In this session of the lecture, we will be continuing with the OSI model as well as network devices. On this topic, we are going to invite Dr. Pavitra Bharadwaj to speak, and let's ask Dr. Bharadwaj to resume the lecture. Welcome, ma'am.
So, we were discussing the 7 layers of the OSI model. In this we had talked about the physical layer and the data link layer. Now we are going to continue with the third layer, that is the network layer. So basically we had said that the physical layer of the OSI model, it takes care of the transmission of the physical transmission of the bits, streams of bits on the medium. The data link layer looks at the division of these bits, the streams of bits into frames. it inserts the header and the header which contains the receiver's and or the sender's address into it. Then we have the network layer. In this network layer, it is responsible for the delivery of individual packets from the source host to the destination host. So, in this diagram we can see that the network layer from the it is connected to the transport layer on above it and to the data link layer below the network layer. Then at the receiving end, it is connected, it takes in data from the data link layer and then transmits this data to the transport layer. So, the network layer at the receiver is going to remove the header, that is the H3 header which is being introduced by the network layer of the receiver. It removes this header and passes on the data to the next higher layer, that is the transport layer. So, basically it is responsible for delivery of packets from the source host to the destination host. So, it is in this case the protocol unit is the packet and it ensures end-to-end delivery of packets possibly over multiple networks. So, here we say that it is concerned with logical addressing. Logical addressing means that the packet which is being sent or which is being received from the data link layer will be delivered directly to the computer. That is, it is not a hop to hop delivery like in case of a data link layer, but it is a delivery of the packet from the source to the destination computer. Even if the destination computer is on another network, then also this network layer will ensure that the packet has been delivered to the correct host or to the correct receiver computer, not just to the next hop, just in case of data link layer. Then one very important concept or very important function of the network layer is the routing. Now, what is routing? Basically, routing means that the shortest path determination. Routing is actually carried on by a specific device which is known as a router. So, a router is a specific device which stores a table called the routing table, which stores the path of every computer or every host to every other host on the network. So, it will ensure that the packet is delivered to the correct host computer through the shortest possible path on the network. So, it hides basically it hides the lower layers physical components and making things hardware independent. So, it uses a logical hierarchical addressing. So, logical addresses, they do not change when a node is moved to a new subset. The devices that work at the network layer are routers and firewalls. So, if you see in this slide, in this case again we will see, like in the data link layer, we see that the delivery is from hop to hop, but here the delivery is from source to destination. So, this slide shows that if the computer A is sending a packet from computer A to the computer F, then the intermediate hosts or the intermediate devices which are marked by crosses, which are actually routers. So, this router will show the shortest path, will find out which path to take if the destination address is F, and then it will redirect the packet to the router E. So, the router E will then detect that the packet is destined to reach the host F, and therefore, using the shortest path it will reach there. But in between, it is important to note that the network, data link and physical layers of both the intermediate systems or both the routers are also covered by the packet before it finally reaches its destination computer or destination host. The next layer which comes on top of the network layer is the transport layer. Now, the transport layer is a very crucial layer and is responsible for the delivery of a message from one process to the other. So, as you can see here, the session layer is the layer above the transport layer. So, the transport layer gets the packets from the session layer, then it inserts its header, that is H4 is inserted into the data, and then these packets are passed on to the network layer. The packets, when they reach the destination computer, the network layer passes on the packets to the transport layer. These packets are now called as segments of data. The headers are removed by the transport layer, and then the data is transferred to the session layer of the receiving computer. So, the transport layer, basically the unit of the data is known as a segment. Now, what does a segment basically mean? See, we have seen that network layer, it treats each packet of data independently. So, whether or not they belong to the same message, the network layer will not bother about delivering those packets in any kind of order. But the transport layer ensures that each packet arrives intact and in order. Now, this transport layer, it ensures this by a process called segmentation. So, it actually gives a segment number to each of the packets. So, when the packets are sent via the network, the segment number is checked, and when they are received by the receiver, again they are put in order by the segment number. So, therefore, if the segments belong to the same message, then they arrive in order at the receiver end. Then an important aspect is service point address, which is more often called as a port. It is used to track multiple sessions between the same systems. Service point addresses are used to allow a node to offer more than one service. Messages not only reach the correct computer, but also at the desired process running on it. So, actually what is happening here is that on the same computer, several processes are running at any given time. So, if a packet reaches a particular computer, it is important to understand at which particular process the packet must be delivered. So, network layer, it only talks about the delivery at the destined computer, but on the same computer, if multiple processes are running, then the transport layer has this important function of ensuring that the packet reaches the correct process for which it was sent, and this is ensured by the delivery at the specific port. So, port basically means service point address or SPA. So, each service which is running, each active service which is running on a computer is utilizing some port, and that port is the identification of the process which is running on the computer at that particular interface. So, the message or the segment will be delivered to that particular process. So, segmentation is done, and then reassembly is also done by the transport layer. So, once the segment numbers are checked, the messages are reassembled at the receiving end and they are put in correct order so that the host can easily reconfigure the message which it has received. Now, transport layer can work as both connectionless and connection oriented service. Now, a connectionless service means that the transport layer of the receiving computer will send the segments without any active connection by the transport layer of the receiving computer. But a connection oriented transport communication means that before the packets or the segments are actually sent on the transport layer, a connection is established, a dedicated connection is established. So, they require the sender to first send a request for a connection, the receiver to acknowledge the connection, and then they negotiate how much data can be sent or received before its reception is acknowledged. So, this connection oriented service means that the connection is established, the data is sent, and once the data sending has been completed, then the connection will be terminated. The next important function is that of flow control. The flow control is another function of the data link layer also, but the data link layer will only look at flow control at the specific nodes. But here the transport layer flow control involves the flow of packets or segments is controlled at a specific process, not at a requisite host. Then because the segments are numbered here and then they are reconfigured and reassembled at the host, therefore error detection becomes very easy. Not just detection but also correction of error takes place at the transport layer. So error control, error detection or error correction both take place by acknowledgement and retransmission. So in case a packet is lost or it is duplicated or there is a defect in the packet which is being received, then it can be either retransmitted or it can be removed, because the same packet is being received or the same segment number has already been received. Therefore, we say that transport layer allows a very reliable point to point or process to process delivery on the computer network. So, this diagram here shows that sender computer has got several processes which are running. The two computers are connected through the internet. So, network layer host to host delivery takes place, but transport layer delivers at the process level. So, it is a process to process delivery which the transport layer is taking care of. The next layer high up above the transport layer is the session layer. Now, the session layer takes data from the presentation layer and it adds some kind of header bits and synchronization bits to it, and then it transfers the data to the transport layer. The transport layer of the receiving computer receives the data and the session layer will remove the headers which were inserted by the session layer of the sending computer, and it will pass on those bits to the presentation layer. So, basically the session layer is responsible for synchronization and control of flow, and it also establishes a dialogue between the two layers. So, here the PDU is the data. From here on it will remain, the PDU will remain the data only. PDU stands for protocol data unit. Now, sometimes the session layer is also called the dialogue controller because it establishes, maintains and terminates sessions between application. So, it makes sure that there is a dialogue. The dialogue is possible through a connection. The active connection is maintained between the two computers. Once the connection is established, the exchange of data will take place, and once the acknowledgement bit is received by the receiver, by the sender, then it means that the data has been received, and then the connection will be, the session will be terminated, or the dialogue will be terminated. Now, this dialogue connection or this dialogue controller works in two modes. It can either be in half duplex mode or in full duplex mode. Half duplex mode means that at any given point only one of the devices will send the data, the other will receive, and at other times the other device can send the data. And full duplex means that both the devices are capable and are allowed to send the data or the messages simultaneously at any given point of time. So, it basically defines checkpoints for acknowledgements during sessions between applications. Now, what are checkpoints? Checkpoints means that if large files are to be sent, then after some number of records a checkpoint is put. Like for example, if a 2000 page file is to be sent across a network, then checkpoints could be put after every 500 pages. So, in case there is a failure which takes place after say page number 540, then the next sending of the packet will start from packet or the data packet 501 onwards. The entire block of data does not need to be resent. Therefore, session layer ensures that the packets are delivered in order and in case there is a failure or in case there is a problem or error in the packets or in the data which is being sent, then it can be rectified from a particular point and the whole transaction need not be redone. So, saving a lot of resources of the network. Therefore, checkpoints is a very important function of the sessions layer. So, it defines checkpoints for acknowledgements and between application. Then besides this, it also provides for atomization. Atomization means that when multiple connections are there, they can be treated as one virtual session. If one fails or if one is terminated, all should be terminated. Then session layer identifies raw data as either application data or session control information. So, it is an intelligent layer which can make the difference between the two types of data which is being sent. It uses the field providers by layer 3 and 4 to track dialogues between applications and services. It provides translations for naming services also. So, we have discussed so far that there is a physical layer, then we have the data link layer which converts the bits of data into streams called frames, then we have the data link layer, then we have the network layer which divides those frames into segments, then we have the session layer, the transport layer. Now we come to the sixth or the higher level layer which is known as the presentation layer. So, as we have already said that the PDU for the session layer onwards is data, and these layers are more user oriented or user specific layers. These are software oriented layers which work at the software level, not at the hardware level. So, the presentation layer is responsible for translation, compression and encryption. So, we can see in this diagram that the presentation layer, it receives the data from the application layer, then it inserts its header called, say in this it is represented by H6, and it transfers this to the lower layer, that is to the session layer. Again at the receiving layer, the presentation layer receives the data from the session layer, it unwraps the data, it removes the header, that is the H6 header, and passes on this information or this data which it has received to the application layer of the receiving computer. So, basically presentation layer performs three important functions. One is data translation, second is data compression, and the third is data encryption. So, it is basically concerned with the syntax and the semantics of the information being exchanged. So, it looks at data formatting, translation, encryption and compression. Now, what is data translation? Data translation means there is interoperability between the different coding schemes, like we have the ASCII or the EBCDIC, etc. So, what it does is that it transfers, it translates or it converts the data from the sender dependent to a common format, and then from the common format at the receiving end, the receiver's presentation layer converts it from the common format to the receiver dependent format. Now, what we are saying here is that when data is exchanged on the internet, then data is exchanged in multiple formats, multiple coding schemes. There are different coding schemes like the binary coded scheme or the extended binary coded decimal interchange, or we have the ASCII scheme. So, when numbers are sent, numbers can be sent directly in the form of binary form, but in case text is sent, then this text is sent in a codified form. As we understand that the internet is an heterogeneous kind of environment, therefore, different sending computers will have different coding formats. So, in this scenario, when a computer is sending an information to another computer which is not following the same coding scheme as the sender, what needs to be done? Then the presentation layer takes the charge. What it does is that it accepts the data which is coded in the sender's coding scheme. For example, say it is coded in the ASCII scheme, and it converts it into a common format. So after the presentation layer, the data will be sent using the common format of the network or of the protocol suite which is being utilized. Now this common format, data in common format, reaches the receiving computer or the destination computer. Now the presentation layer accepts the data in the common format, and then it again translates this data into the format which is specific to the receiver or the host computer. So this format, say, could be a Unicode format. So what is happening is that a computer that had sent the data in ASCII format can now communicate with another computer which is actually using the Unicode format. So two computers which have different coding schemes can still communicate with each other because their presentation layers have been so formatted. Next is data compression. We understand that internet is a way where large size files like multimedia, text, audio, video, sound, etc. are sent. So the presentation layer of the network will work towards compressing these files so that their length is reduced, they become lighter, and they can be easily transported over the network. Then we have encryption. Encryption is another important feature of the presentation layer. We understand that several sensitive data information pieces are sent on the internet. So this sensitive information is actually sent in a codified format called the ciphertext or in a hidden format. So this file is known as encrypted file. When this encrypted file, it reaches the presentation layer of the host or the destination host, then the presentation layer there will do the decryption of it. That is, it will convert this encrypted file into the plain text or into the format in which it can be easily read. So this change from plain text to encrypted file and then from encrypted file back to plain text is also done by the presentation layer of the receiver and the sender computer. So thus the presentation layer talks about the syntax and the semantics of the information which is being transmitted. The next layer that we talk about is the application layer. Now the application layer is the highest layer of the OSI model. It is responsible for providing services to the user. So they use the users could be a human being or it could be programs. They take the services, and these services or these instructions, they are converted into data, and this data is sent to the presentation layer. And the opposite happens at the receiving end. The data from the presentation layer is taken by the application layer and is given to the specific services for the user or the program. So it provides communication services to the applications like HTTP, FTP, SMTP, etc. So different services are provided by the application layer, like the network virtual machine, which provides for remote login. So a network virtual terminal basically allows a person to log in to a computer, to a remote computer, just as if he is or she is logging to a local computer. You can use all the functionalities, all the softwares, programs, etc. which are there on the remote computer, just like they are on the user's own computer. Then there is file transfer, access and management system, where files can be easily downloaded and uploaded on remote computers using this access and management system of the application layer. Then of course there are mailing services through which emails can be sent and received. Different formats of the emails can be sent and received. And then there are directory services through which databases can be accessed and received. So finally, we have seen that there are 7 layers in the OSI model, and in this lecture we have seen the different functions of each of these layers. Different protocols work at each of these layers. So this slide shows the summary of all the layers that we have discussed. the physical layer which transmits the bits over the medium, electrical and mechanical in nature, data link which ensures hop-to-hop delivery, network layer which moves packets from source to destination and it provides internetworking, transport layer which provides reliable process-to-process message delivery and error recovery, session layer establishes, manages and terminates sessions between the two computers, it is the dialog controller. Presentation layer looks at translation, encryption and compression of data, and application layer which allows communication between the users and the programs on the network. So, with this we come to an end to the OSI model. Thank you.
Dear friends, in this lecture we have tried to understand the concept of OSI model. On that note, we would like to thank Dr. Pavitra Bharadwaj for coming here and delivering this wonderful lecture, and thank you dear friends for watching our lecture. Stay tuned and keep watching. Thank you.